everyone, and welcome to this Splunk B-side session. My name is Alex Teixeira, and today I'm going to be presenting you how to detect authentication brute force attacks with Splunk. A little bit about my professional self. I have over 15 years of professional experience in information security. I'm also a former Splunk employee. I was a member of the professional services organization between 2015 and 2017. After that, I basically started working as a freelancer. The last 4 to 5 years solely focused on detection engineering. And I have recently joined an MDR provider based in US as a senior content engineer, where I also have a chance to work with different detection technologies and also to focus a little bit more on detection research. So what's the reason, the main reason for this talk? The first one is because virtually every modern computer system is a potential target of brute force attacks, right? Assuming there is an authentication system and you need to have credentials to access this system, brute force is definitely one of the techniques that an attacker can leverage to get access to it. But the main reason for this talk is because I want just to share another way we can leverage SPL to detect attacks, especially this brute force one. So what's a brute force attack? Basically, a brute force is a technique that is implied by an attacker to systematically guess the password of an account, right? For those that are not into detection engineering, MITRE is a non-profit American organization that, among many things, they have created a framework called ATT&CK, where they lay out many different techniques used by attackers. And one of those is, of course, the brute force. And here they also break it down into 4 different sub-techniques. I'm going to be focusing on the password guessing and the password spraying ones. Here's another piece of motivation for us. If within our InfoSec industry, there is a very famous and respected report known as the BIR, or the Data Breach Investigations Report. And from there, we can see that the brute force plays a very, very important role, especially if you are designing or doing any sort of threat modeling exercise within an organization. 45% of the breaches, they feature one tactic called hacking. And within this tactic, you can see here around 80% of the activity within this tactic is around brute force or the use of stolen credentials, right? So what makes it a potential attack? So what are the traces, or what are the characteristics that I'm looking for when I'm designing this sort of detection? I need to know how many accounts are being targeted. I need to know what's the attack time span, how much time when the attack started, when the attack ended, how many origins are involved in the attack. If the attack is coming only from one single source IP, or if it's coming from multiple IPs. What's the number of attempts per target account? I want also to, this is basically the main threshold, right? How many failed attempts are happening towards the same targets? And I also need to know if there was a successful authentication among those, the attempts, the failed authentication events. Here is a little bit about which data sources, or what kind of data sources we could leverage to detect this kind of activity. Vast majority of customers or environments, they will provide VPN logs, Windows event logs, signing or cloud related logs. and also Unix or network devices, syslog messages. And from those, you can basically use the events or those logs to detect this kind of activity. For here, mainly for Splunk environments, some of those environments, they will leverage, especially the ones using enterprise security app, they will leverage data models, right? And that means the events are already complying with the common information model. So there is a certain level of event normalization going on. And we need to focus on the tag equals authentication and the action fields and other fields that are part of the authentication data model. A few customers, they will have their custom, let's say, alert frameworks. They will be basically consolidating or summarizing or aggregating all the relevant authentication events in summary indexes, or they might also accelerate just certain fields, the relevant fields that I'm listing here down below, that will make their queries a little bit faster by using index field extractions, right? When we talk about relevant fields, as I said, we have the origin, meaning the source host or the source IP. We have the target, meaning a user account. This can also be a combination of the user account and the destination host or the destination IP. Think about, for example, a Unix system that is not part of Active Directory. You also need to take into account the destination hosts as part of the target. And of course, we also have the action fields, basically the outcome of the attempt of the activity, if it was successful or if it has failed. I also mentioned here that for 365, any other LDAP, Active Directory authentication based, most of those times you don't need to care about the destination hosts, since the authentication is sort of global, right? So this is the main focus here. This is the very important part of this presentation. This is going to be the most important piece to understand how the different, why I'm applying different techniques to detect different kind of attacks. Basically, we need to understand what are the different types of brute force attacks, right? The main one, which I also call the vanilla attack, is basically I have a single account, and I basically, the attacker targets a single account, and it always comes from the same source, right? This means that the trigger condition is basically around if I have more than a certain number of attempts within a certain short time frame. And the scenario here is basically too many attempts against the same target from the same origin. And the footprint for that is sort of medium, right? Depending on the technique or how stealth the attack is. We also have a mass account brute force. This is basically another way to describe it. There are many ways, many angles you can see this. But I'm basically saying that a mass account brute force is when multiple instances of the vanilla type of attack comes from the same origin, affecting too many or multiple accounts. This is, of course, a very noisy version of this. And this is basically how most of those internet scanners and bots, they work. So the footprint is pretty high. We also have a more, let's say, a more modern approach for this kind of brute force attack, which is called password spray, when multiple accounts are involved and it's always coming from a single origin, right? We have more than a certain number of targets coming from the same, let's say, source IP or same host name. And when the average number of attempts is below or equals to the threshold that was set for the vanilla attack type. So let's say I'm going to alert whenever the number of attempts is above 5. If the number of attempts is below 5, equals or below 5, and this is touching on multiple targets, that's basically when I have the password spray behavior there. So it detects attacks that are below the vanilla thresholds towards multiple targets, even if they are low and slow, right? And the footprint, of course, this may vary a lot because I can, the attacker can apply this or perform this attack against many multiple accounts, or it can also be only done against just a few, right? And then we have the targeted account brute force. This is when a single account and multiple origins are involved. So the main threshold here is when there are more than certain number of origins observed towards the same target account, not matching a default one, right? Think about this one. Some attacker just made he or she recently discovered that there are many accounts that are important within the targets, and those accounts are not the default ones, including admin, root, backup, and things like that. So he is able to craft this kind of custom attack towards those very specific accounts, and originating from different IPs or different sources, so that it won't trigger the vanilla brute force kind of detection. So this is the more specific one, and it of course has a lower footprint as compared to the other. It's worth noting that of course we can have overlapping types within one single scenario, and I'm going to talk a little bit about that later. So for just explaining how we could do this with Splunk, of course, we need to leverage data, and I have crafted a little data set with multiple brute force attack instances and types, which can also be easily customized for using SPL commands. Here is basically how this data set is created. Not anything fancy, not using event gen or any attack simulation framework. I'm basically using Splunk language itself. As you can see here, I use a series of append commands just because it's very easy. I just did some copy and pasting, and with that, I basically set the time for each of those attacks in a certain offset compared to the now time, right? So all those attacks, they will be within 1 hour. And in the end, I basically collect all those this output to an index called authentication or auth, right? Some of those events, they also include, of course, some noise, some legitimate or some events that we would not trigger, should not trigger the detections. And of course, you can expand these to anything that you like, right? And here, basically, I'm describing the high-level plan, right? What is basically within this data set? You can see I have multiple types of attacks, account brute force, this one only with failed attempts. I also have one with with failed and successful attempts. I have a mass account brute force, fast password spray, slow successful password spray. So all of those are within those events, that data set, and they are coming from different sources. So just to make it very simple and more didactic, I'm using only source and user. I'm not using source IP or destination IP. So the meaning that the attacker is basically coming from a source name, and the target is basically a user account, right? You can use this as a reference if you want to play with that in your lab, and it should match basically the description that is here should match the data set. I'm also providing a sort of stealth brute force attack that I'm going to review in the end. That is not going to be caught by the usual brute force detection techniques. So here's just a quick summary of the data set split by source or the origin. You can see the total number of events per source, right? You can see an aggregated value with all the targets for each source that is represented in this table. You can see the pattern here of the pinky source performing this low and slow attack. While you can see also this speedy source generating 59 out of those 123 events, so with a higher footprint. And of course, multiple different combinations of the outcome, right? The action can be failure or success following the common information model. So what's the detection strategy? So how can we basically pinpoint all those different attack types from the data set? So we are going to assume, since all the events are within 1 hour time frame, we run this every 1 hour, and we are of course looking back 1 hour. So assuming the time is is sorted and there are no issues with time zones and things like that. And of course, we are going to leverage multiple stats commands to detect this kind of these different brute force attack types. For the fast attacks, we are going to, I'm just picking 10 seconds window. And for the others, we are going to use the whole time frame that is looked back, so 1 hour. Of course, with that 10 seconds is just a suggestion. You can basically customize it for any time frame you want. And then we are going to aggregate alerts by attack flows, right? And I'm going to touch on the attack flows a little bit later. What is the advantage of those? We are going to have a faster alert triage. We are also going to focus on the bigger picture, and we are going to leverage basically the data analytics features from Splunk. So what would be a pseudocode? Basically, I'm going to collect events. I'm going to bin the events in 10 seconds buckets. Then I'm going to leverage the stats command and aggregate all the events by origin and targets. And from there, I can basically, with this kind of aggregation, I can detect the vanilla attack by counting the number of attempts. Then with event stats by origin, I'm able to detect 2 more types of attacks. One is counting the number of vanilla attacks, which is the mass brute force attack. And another one, the password spray, I basically need to know how many distinct targets were observed from the same origin. Later, I use again event stats, this time split by targets to detect the targeted attack, counting basically the number of origins that were seen. I later filter in attacks. After doing all those event stats, I'm able to determine the signatures or the attack types. And in the end, I basically just aggregate all those attacks detected by attack flows. So here we basically get into the first the first part of the detection rule. I'm going to start breaking it down into small pieces, and this is of course the beginning of it, the base search, where I basically need to scope on the potential data sources. Since we have only the demo data set, that's what I'm doing here. And I suggest you, of course, you can leverage, and these are basically the few lines that you need to change in order to leverage the same kind of detection technique. I also, as you can see here, this is the first stats that I mentioned before. I'm going to split the events by origin, target, and the time span. And you can see the time span is basically coming from the time, the underscore time value, right? For those that use different field names, they want you want to apply this technique to other columns or other fields. I'm also suggesting here how you can do it. And in the end, you basically just need to rename your source as origin or your target as, in this case, user as target, right? Here, I'm also suggesting how you can differentiate between a failure and a successful, a failed and then a successful event. You can basically just add in these regex everything that would match the different scenarios. Yeah, I'm just explaining there how it goes. And in the end, you have something like this in the output. So if I run this detection up to this line, that's basically the type of output that I'm going to get. You can see already for Bird and for Blinky, Blinky has made 7 attempts in total. 6 of those they failed, and 1 was successful. And for Bird, 1 was successful. And of course, targeting different users or user accounts. Moving on, this is the first detection, the first attack that we are going to detect. This is the very same stats that you saw before. And I'm highlighting here what are the important parts, right? And for every attack, we are going to generate a signature that is going to be accumulated over. And you have an attack threshold that you basically can set for each of those detection types that you see later. So this is the only thing you don't, if you want to leverage this kind of technique, you don't need to change anything. Or if you want to customize, of course you can, but the only thing you need to do is, of course, define what is a failed attempt, a successful attempt, and then adjust the thresholds for your environment. One thing that I like to leverage in the detection that I write is the reason field, which is also part of the common information model, which is basically describing why the alert is being fired. So here you have a full description, all the subjects involved in the attack, time frames, all the important metrics, everything is in one place. I also have a quick flag just to differentiate if the target, if the user account is a default one or not. And you can add as many other entries here as you want. I will later also recommend you can also use, of course, macros or lookups in order to do that. And here are basically here's the output, just like before, of the detection up to this point, focusing only on the vanilla type of attacks. You can see here in the output, there are some legitimate instances or the noise that I'm creating. Those are not detected as attacks. You can see that the reason in the signature column or signature fields, they are empty. While for example, Blinky, this origin, you can see there is a potential successful brute force attack related to this activity coming from this source, right? Speedy is involved in multiple attacks against multiple accounts. You can see multiple lines here for Speedy, right? Yeah, from this origin, there were at least eight failed attempts towards different user accounts. You see admin and you see contact here, and those are going to have its own record in the output. As I mentioned, successful highlighted here, while this one is not successful because there is no, of course, no successful event within the same time frame. Now we go for the mass and spray attack detection. I'm just as you can see here, we are already at line 25, and here is where I start basically crafting. This is a little bit bigger because we are, of course, detecting two detection types. Just leveraging this part of the code where we have the aggregation by origin, right? You can see here I'm leveraging another event stats, which by the way has no this data destructive nature as the stats command. So everything that happened before is still available within this context. If you think about how the events are streaming into Splunk or into this into the engine. Here I can also define or customize another threshold. And similarly, I can do the same for the password spray. I have another threshold here that I can set. What I'm starting to do here is basically using MV append, so that whenever I detect starting from this point, I basically accumulated or aggregated over the signature of the reason field. So you see for all the signature and reason fields, I'm now starting to use MV append, so that I'm able to accumulate different metrics or different values per origin or per target. So that's where I flagged the targets. What is considered a brute force target? What is considered an actual attack target? These are variables that I'm going to use afterwards. And those are basically the conditions, right? Or the trigger. What is the behavior I'm looking for in order to determine that there was a mass brute force attack, right? And here you can see basically when I have this attack flag, this is where the main condition is described, right? I need to have the count of brute force targets greater than the attack threshold. That's basically the main threshold or the main condition to determine a mass brute force attack. Similarly, I have the attack flag for the password spray, and this is a little bit different. I may have a successful password spray attack or a non-successful one. So here I basically combine those conditions, and I'm able to tell when there is a potential successful attack or not, right? And you can see similarly, like before, the outputs, I'm just filtering in a few columns so that it's easier to display. You can see pinky origin with 6 failed attempts and 1 successful within the same time frame against the target admin. And the description, so the full reason why this is actually happening, right? You can see also the number of targets and the targets itself, the targets themselves, and also the time frame within when the attack actually happened. Again, I'm highlighting here Speedy, which is the very noisy attack. It triggers the threshold for the mass attack. So it was previously detected from the vanilla attack, but it's also related to multiple targets. So we can easily say, okay, this speedy origin is actually a very noise attack, and we can treat this as in a different way. You can have different playbooks, or you can assign different priorities or severities to this kind of attack. And you see here for the shadow, this is just one instance of multiple attacks that that are originating from this origin, right? So he's in this case he's targeting 7 account targets, and in the end you see how this is going to end up in an aggregated attack flow. And the last attack that is that we are going to explain is the targeted attack. In this case, I'm again leveraging the event stats and aggregating by target. And you can see the threshold is also available here to be customized. And you can also, of course, consume or collect these thresholds from lookups in case you want to craft a more elaborated detection. Basically, here I flag the origins that I would need in order to determine if the conditions for if the conditions are met. And basically here is where in the attack flag, following the same methodology as provided before, I have basically in this case I also have I may have successful and non-successful ones, and I'm able basically to determine with a case eval case statement if the conditions were met or not. In the output, again the same. You see bird origin 3 times here, targeting multiple accounts, right? And you can see when in the reason field and also in the signature field when there is a successful or not attack, right? In the end, I also need to summarize this. We are talking about 123 events, but of course, in production, especially talking about authentication related events, we can easily go over millions, if not billions of events, right? Especially depending on how much time you are looking back in order to detect this kind of attack. So we need to leverage some sort of summarization technique in order to reduce the volume of attacks, of events, of alerts, but also to make it a little bit easier to see the bigger picture. So it will make life easier for SOC, for analysts to triage and also to combine or aggregate these kind of events into other cases, right? From here on, I start using the stats command. Everything that I needed until this point, I have already consumed. So I'm safe to use the stats command. It will make my query a little bit faster. And I will basically just need the information that I'm listing here in the stats statement. So I'm aggregating here by origin, which is the best bet for any kind of, not any kind, but for most detections, it's always a good idea to aggregate by origin. And after that, I basically calculate a hash of the attack, right? This would be basically what are the distinct scenarios that I need to investigate as an analyst, right? That's basically what I'm doing here. And since I collect all the information in the reason field, that's the only thing that I need to focus on in order to hash or to uniquely identify this attack flow, right? If you have, for example, if you want to do this by different source types, or if you are in a multi-tenant environment where you have client or tenant information, that's probably another value that you want to add to this MV append so that it will also treat the attack flow a little bit different. After that, I do another stats, and in this case, I aggregate by the attack hash. And finally, I basically just rename the origin and the target fields into the original ones, which are source and user. And here I'm just suggesting you can basically do some sort of alert normalization where you can basically have a consistent way of outputting the alerts to any other workflow that you are going to leverage afterward, for example, in your SOAR or in your case management system, right? And now we are going to see the full result. So this is basically the output of that detection query. And you see we have start time, we have end time, all those are already mapped to this Splunk Common Information Model. So they will be ready to be displayed in the incident review dashboard in enterprise security in case you use this. And you can see we basically have 7 attack flows out of those 123 events, and with multiple sources, right? You can see here how this is basically in the end, how this is described. I can clearly see, for example, multiple sources here. The NBA stars, right? They targeted 3 accounts, and among those there were successful and non-successful ones. So if myself as analyst, I would investigate this, I would see the bigger picture instead of one alert from Bird, one alert from Clyde, one alert from Johnson, and so on, right? Similarly, you can also see here the source shadow performing a potential password spray attack and targeting multiple accounts. And I can also see from the description and the reason what was the behavior of it, when it happened, and so on, right? This is a very good summarization of all the attacks that happen. You see here for the speedy, the noise attack, the very beginning of it, it says there were multiple potential brute force attacks originating from the source, which constitutes basically a mass brute force attack, right? And the Blinky basically was the one that performed the successful brute force attack. Yeah, this is basically just highlighting what I have already spoken about. You see here the unlucky attacker, Pokey, is going towards the admin account. He was not able to, at least within this time frame, not able to successfully guess the password, while this Blinky source was able to guess, probably or potentially guess, the password for the account, the backup account. So this is basically the surprise for this demo, for this talk. We need to understand that if this attack is really important, is really prevalent, we need to leverage as many ways as possible to reliably detect it. And I haven't shown this in the initial screen, but there are 3 extra lines that I use in that demo data set. And those are basically originating from source D Carasso towards the user Buttercup, right? And I'm using streamstats here just to carefully craft the time that is going to be assigned in the end for each of those actions. You see here 3 actions are related to failure failed authentications. And then after that, I generate 3 more, and the last one is, of course, the successful one. This is actually within the demo data set, but by leveraging the usual detection for brute force, we are not able to detect this one. Basically, it goes missing, right? It goes under the radar. What happens here? Why we are not detecting this one? You can clearly see when you basically apply, when you list the time in a sorted order, you can see the seconds are 7, 8, 9, 10, and then it goes on. If you just leverage the bin command, bin is basically going to snap to the 10th second, right? Meaning all the ones ending with 0. So what happens is we have two time windows, one starting with the 0.7 seconds, one and ending with the 0.9. So you have the first 3 events in the first time window, and then the other window accommodates the last 3 failed attempts plus the successful one. And both of those time windows, they do not meet the threshold criteria, which is set to 5, so greater than 5, right? So this is why this basically goes under the radar. So I'm just highlighting there the snap to 10th, the 10th second behavior, and the attack basically spanning across 2 consecutive time windows, right? So how we can fix that? Again, we basically leverage another stats Splunk command called streamstats, and we basically just need to remove the bin command that we had before, and we need to have, of course, just to make sure the events are sorted. We add that sort command. For those that are into performance, of course, this is not um, a good practice. But if we are running these over 1 hour, over 30 minutes, or even smaller time frames, the impact is very, very low. So I basically changed the bin command to a sort and stream stats command, where I have a possibility to provide this time underscore window parameter, basically telling, okay, whenever you see one event coming from a different origin and target combination, you basically start the clock. So the clock starts whenever there is the first event is seen from each of those tuples, right? And it ends, of course, when the 10 second is over, and we have a 10,000 events limit by default. So this is set on limits.conf. So if I do that, this is basically the output of the stream stats, just to demonstrate that the time span is basically different. It's not bound, it's not snapping to the 10th second. You don't see the 0 there, but you actually see the first time if you construct the stream stats this way with mean underscore time as t span. You see basically the session identifier is the first time the event is seen from a certain origin and target combination. And this way, we are basically able to see all the events from the Carasso source towards a user Buttercup. They actually fall into the same single time window, which meets the threshold so that it outputs from that detection, right? And then you can see here the missing attack, the potential successful brute force attack available in our output, even including the 6 failed attempts and of course 1 successful login observed from that origin. All the SPL artifacts are basically, we are talking about 2 searches, one to generate the data set and the main detection query. They are available from this GitHub, and the slides and everything will be available from the Splunk community website. Here are just a few, for those that are into detection engineering. Of course, this is just a sort of template for a brute force detection. There are many things that we can improve here, and there are multiple ways actually to do that with Splunk. But just a few things to consider. should consider these results as indicators, right? In case you have a custom alert framework such as RBA, UBA in place. You can also apply scores and factors depending on the signature mainly. You can also combine these with other fields part of the output. For MSSPs or multi-tenant environments, you simply add the tenant or the customer information to all the stats comments. So you add this to the group by clause, and you basically have the same detection there for your multi-tenant environments. Same applies for users or customers using the authentication data model. If you want to split those detections, it makes all sense, of course, to split those by source type. You basically just add the source type to the group by clause. Of course, if you want to scale, you need to use macros or lookups for dynamic thresholds based on different environments, based on different data sources or different customers, right? And you can also consider a potential account abuse or compromise use case next. Think about, this is the brute force mainly focus on the failed attempts. Since if you are able to understand how this behavior works, and if you are already applying this to your environment, it makes all sense also to focus on the successful events only. Think about, for example, concurrent logins from multiple locations, and also password sharing, these kind of use cases. Yeah, and that's all I had. If you have questions, feedback, I'm also going to be around, in the Splunk users Slack. I'm looking forward to, have a chat with you. Thank you very much.